Chapter 8 VPN and the IPsec concepts. In this chapter, we are going to cover following sessions. 8.0 The Introduction, 8.1 VPN Technology, 8.2 The Types of VPNs, 8.3 IPsec. 8.1 VPN Technology. As organizations expand, employees often need to access company resources from branch offices, home offices, or while traveling. However, sending this sensitive data directly across the public internet is not secure. To solve the problem, the organizations use virtual private networks called VPNs. So, what is a VPN? A VPN creates a secure end-to-end connection between users or sites over the internet. Although the internet is a public network, a VPN allows it to function like a private network. This enables users to communicate securely without requiring a dedicated private connection. So what is called virtual? A VPN is called virtual because there's no physical private cable connecting the two locations. Instead, the data travels over the public internet. The connection behaves as if the two sites were directly connected, even though the internet is carrying traffic. What is called private? A VPN is called private because the data is encrypted before it's transmitted. Encryption converts readable data into an unreadable format. If someone intercepts the traffic while it is crossing the internet, they cannot understand the information without the proper encryption keys. This protects the confidentiality of the data. There are different types of VPN connections. As shown in the figure, an organization can use different types of VPN to securely connect its main site with remote location and remote users. Although the connection travel across the public internet, each VPN creates a secure, encrypted tunnel between the endpoints. Think of the VPN tunnel as a protected pathway through the internet. Anyone outside the tunnel can see that data is being transmitted, but they cannot read the encrypted information inside. The first VPN technologies were much simpler than the VPNs we use now. Early VPNs focused only on creating a tunnel between two locations. They did not provide authentication or encryption. This means the data could travel through the tunnel, but it was not protected from someone who intercepted the traffic. 8.1.2 VPN Benefits. Modern VPNs provide much more than just a tunnel. Unlike early tunneling protocols such as GRE, modern VPN includes security features that protect data while it travels across the internet. The two most common VPN technologies are IPsec VPN and the SSL VPN. Both create secure connection, but they are designed for different purposes. The table here shows the major benefits of VPNs. Number one, that's the cost savings. It reduces networking costs by using the public internet instead of expensive private WAN links. And then we have the security benefit. Protect data with encryption and authentication. Also, its scalability. Easily support new users and locations without significantly infrastructure changes. Compatibility. It operates over a wide variety of internet and broadband technologies, enabling secure access from virtually anywhere. These benefits make VPNs a cost-effective, secure, and flexible solution for connecting remote user and the branch office to an organization's network. Organizations typically deploy VPNs in one of two configurations: the site-to-site VPN, also the remote access VPN. Both provide secure communication over the internet, but they serve different purposes. One of the most important and common VPN deployment is the site-to-site VPN. A site-to-site VPN securely connects to entire networks over the public internet. Instead of individual users establishing VPN connections, the VPN gateways at each side automatically create a secure tunnel. The second common VPN deployment is the remote access VPN. Unlike a site-to-site VPN, which connects two networks, a remote access VPN connects an individual user to the corporate network. It provides a secure connection between a client and a VPN gateway. There are several ways to secure traffic between organizations' locations. The solution an organization chooses often depends on who manages the VPN. Generally, VPN solutions fall into two categories: enterprise VPNs and the service provider VPNs. An enterprise VPN is owned, configured, and managed by the organization itself. The company's IT department is responsible for configuring the VPN gateways, managing encryption and authentication, monitoring and maintaining VPN. Enterprise VPN typically use IPsec VPNs for secure site-to-site connections, SSL VPNs for secure remote access connections. For example, a company's headquarters and a branch office are connected using the IPsec site-to-site VPN, while employees working from home connecting using an SSL remote access VPN. The enterprise has complete control over the VPN configuration and the security policies. And then we have the service provider VPN. A service provider VPN is managed by the Internet Service Provider, the ISP, or another telecommunications provider. Instead of building VPN tunnels across the public internet, the provider creates secure connection with its own network. One of the most common technologies used is multi-protocol label switching, MPLS. This figure summarizes the most common VPN technologies used in enterprise network. Notice that the VPN solutions are divided into two main categories: the enterprise managed VPN, also the service provider managed VPNs. Enterprise managed VPNs are designed, configured, and maintained by the organization's own IT department. These VPNs are divided into site-to-site VPNs and remote access VPNs. The second category is the service provider managed VPNs. In this model, the service provider, not enterprise, manage the WAN infrastructure.